Okay, so we have question 5 from a paper 5 here, perhaps that's one. And we've got a whole story and scenario here. Now, I'm looking at that 3 marks going, wow, I know it's going to take me a while to explain, but you'll see I'm going to write down a few extra things just to get us into thinking this. So the first is just looking at there are 4 boxes and they're placed in order. So I'm taking a long time to do this, but I'm just going to write down we've got our boxes K, L, M, and N. And then there are also 4 marbles. There's a red, green, white, yellow. So I've got red, green, white, yellow. Okay, so we've got an idea of these marbles need to go into the boxes. We could have all sorts of things. We could, of course, have that we've got it in that order. We could have that we've got yellow, white. Can you imagine there are quite a few options? I'll leave it to you to figure out how many options there are, because that's not a trick question. That really is in your bag of how many different options are there altogether. And we'll hit that in a second of what that is now anyway. Okay, now the next part is I'm going to jump to this idea of independence. Well, if 2 events are independent, it means that the probability of A and B occurring is the same as the probability of A times the probability of B. And I can actually add a double if here, because if the probability of A times the probability of B is equal to the probability of A and B, then the events are independent. So in other words, this is what the question's asking us. It's saying work out the probability of A, work out the probability of B, work out the probability of A and B, and show that they're equal to each other if they're independent. If they're not equal to each other, then we're going to state that they are not independent. Okay, so embedded in that independent is guiding us what to do. Now, if you were in the exam situation and weren't sure what to do, there are 2 events. So at the very least, I would definitely be working out the probability of A and the probability of B, even if you have no idea what you need to do. I mean, that feels like a reasonable thing to have to do. Okay, so the probability, our denominator, was what I started with. Well, our denominator for any of our probabilities is going to be all the options that could occur. Well, there are 4 marbles here, and we're putting them into 4 boxes. So easy enough, right? We have 4p4 or 4 factorial. 4 things that we're choosing to put in 4 places where order matters, so permutation. Okay, so that's going to be the denominator for all our probabilities. So let's focus on our numerators and say, wait, how many things can we have? And let's look at our events and make sense of them. A white marble is either in box L or box M. Okay, so I'm going to do this a slowpoke way, and then hopefully you're going to see why I'm saying that it's a slowpoke way. Our white marble could be in L. Well, if that's the case, that must happen. There's only one way of that happening. White's gone, and we're placing 3 objects into 3 boxes. Okay, so that would just be a 3p3. Or the white marble could be in M, so the white marble could be there, in which case there are 3 boxes left to put 3 objects, 3p3. Of course, we're always going to be dividing by 4p4. We said already that's our denominator. That's all the options that there are. Our sample space, I guess, if you will. So this feels a bit silly, because if you work this out, you're going to get a half. And then you might come back and think, wait a second, well, forget all the other stuff, because the white has 4 options to go into, and we've said it must go into one of these 2, so it must go into 2 out of 4, i.e. the probability is just a half. So slowpoke away. Think about it a little bit, and you've saved yourself quite a lot of time in thinking. Okay, now let's get into what the second probability is, and I'm rubbing out all this lovely thinking, but I just want to have everything on screen, and yeah, there we go. Okay, so event B. The red marble is to the left of both the green marble and the yellow marble. So you just want to see how we're getting into this if you're struggling to do that. To go, the red marble is to the left of both the green marble and the yellow marble. So stop by thinking, where must the red marble be? And conversely, where can the red marble not be? Well, the red marble, of course, can't be here because that can't be to the left of two marbles, and nor can the red marble be over here because that won't be to the left. So we've got two scenarios to think about. The red marble could be there, or the red marble could be over there. Now, the red marble is to the left of both the green marble and the yellow marble. Well, in this second scenario, we could have these two things here must have the green and the yellow. Well, there are only two options, right? Green, yellow, or yellow, green. So there's a 2p2 option here, or 2 factorial, and the red must have been over here. And the other option over here is that the green and the yellow marble could be there, there, or there. So we can pick where those want to be. And I'm kind of easing off giving every last bit of detail, if you notice, writing everything down, because I want you to actually just still think about what numbers you're going to write down. You've got those answers there as well to look at, to go, oh, that's where that 2p2 comes in. That's where that 3p3 comes in. So, for this probability, we're choosing here that our green and yellow can be anywhere here. But of course, that just means that we're placing these three things into those three positions over there. Whereas this one, we had to place it only in two places. And this one over here, well, this must be the white marble, right? If the green and yellow are over here, and here was just a 3p3, and here's a 2p2. Times 1 if you want. Okay, so there's that one. Now the last bit, maybe to help you think through, is, well, what would A and B, what would that look like, that event? Well, the white marble is either an L or M. Well, if the white marble is in L or M, let's put it over here. If the white marble's there, and the red marble is to the left of both the green and things, we already said the red marble can't be there, and it can't be there for event B. So for A and B to be true, if the white marble is in L, then the red marble must be there. So there's one option, right, for both of those things to be true. Okay, then you can place the other two. Now, if the white marble is in L or M, where do we just put it? We put it there. If the white marble is over here and the red marble's to the left of both of these, well, of course, the red marble could be here. That would be an option, right? Or, we already said the red marble definitely can't be over there. The red marble, wait, let's just play with this other option. If the red marble were there, and it has to be to the left of the green and yellow, well, what's going here? Green or yellow? Oh, problems. So can you see the idea that I'm hopefully trying to get across here is, as you write down and just see the options start occurring, and you're doing this a little bit quicker than in my explanation here. So you're going, well, white marble, L or M, well, white marble there, red, green, well, that makes sense. White marble over here, well, of course we can't have that. So you're scribbling that out quite quickly and going, oh, well, for A and B, well, we can work this out a little bit easier. And of course, you got your 4p4 in the bottom, and you're saying that your numerator, will you work that out? So now you've got your three probabilities: probability A, probability B, probability A and B, and you see that these events do turn out to be independent. Okay, long explanation, but maybe helps you get into this type of question. I'll see you in the next one. There's another one from this paper coming up. I'm keen for that. Delivered, I think it is.